In this video, we're going to check out the protection features in case of overloaded channels. We're using the adjustable version of PISA-M, which means you can set up each channel individually. Before we start operating, please note the following warning instructions. Read the installation manual for detailed warnings. When setting up the PISA-M, minimum installation clearances of 40 mm on top and 30 mm on the bottom are needed. In case the adjacent device is a heat source, you need 15 mm lateral clearances. Between multiple PISA-M modules, no clearance is needed. Ensure that the main supply is switched off before working. Also, please take note of the following installation hints. Pay attention to ambient conditions and installation clearances. Mount the device on a DIN rail according to EN 60715 with the input terminals facing upwards. Use suitable cables. Please check the installation manual. Check that all 4 rules are properly inserted into the terminal connections. For our first example, we'll look how to reset a trip channel when there is an overload and it is single flashing red. So first we check the current settings by pressing the first and the fourth button. Now we see we have 3 ampere on our first channel. Let's assume we have added 2 amps above the load that channel 1 can handle. In this case, the channel identifies the overload and shows it. It begins to change the color to yellow, and then it begins to single flashing red. You can reset the channel by pressing the related button a bit longer. This reactivates the channel and it will light up green. Please note, however, that the channel only remains activated for a short time and trips again if the channel is still overloaded. Now let's simulate what occurs when we overload channel 2. The current setting for channel 2 is 8 amps, but in this situation, we're dealing with an output current which exceeds the allowed capacity. Now let me explain how the PISA-M device reacts in this case. First, it signals the overload by turning the channel indicator yellow. The tripping can be fast or slow, depending on the tripping characteristic. Then the channel begins single flashing red. Additionally, an overload occurs on channel 1, along with a total device overload exceeding 20 amperes. Now channel 1 is being tripped, lights up in yellow, and then it's double flashing red to signal that there's a total overload. The 2 different types of flashing are clearly showing whether individual channels are overloaded or if there is a total overload. Lastly, let's explore what happens when we simulate a total device overload of more than 20 ampere, but no channel is overloaded. The upper 2 channels are set to 8 amps and the lower 2 to 6. Our power supply can provide up to 28 amps, but the PISA-M can handle a maximum output current of 20 ampere. As a result, the PISA-M turns off the output channels one by one, starting with channel 4, which is double flashing red. This leaves us with 22 ampere, which is still 2 over the limit. Next, it deactivates channel 3 and the output current is 16 amps. Now only channel 1 and 2 are active. So it is important that the most critical loads are connected to channels 1 and 2, while the less critical loads should be connected to channels 3 and 4. To sum up, the PISA-M turns off the output channels one by one, starting with channel 4 and followed by channel 3 until the sum current is less than 20 amps. For this reason, it is essential to prioritize which consumer is most important and which is less important. And that's it. This is how the protection features works. Thank you and goodbye. Thanks for watching. For more, check out our PULS channel or our website.